Good morning. I am K.Rameshchandra, Assistant Professor, ECE Department, Vishnu Institute of Technology. In this lecture, we are going to learn how to perform RC phase shift oscillator using IC741 operational amplifier lab experiment. This experiment done by the students in the third year in linear integrated circuits lab. Our aim is to design RC phase shift oscillator using IC741 operational amplifier and plot the output waveform and measure the frequency of oscillation. After completion of this experiment, students are able to design RC phase shift oscillator for the desired frequency. The following equipments or components are required to perform this experiment. They are dual power supply, because we need to give plus VCC and minus VCC to the operational amplifier. The following resistors are needed: 3.3 kilo ohm resistors, 3 numbers, 33 kilo ohm, 1 mega ohm, 180 kilo ohm, 100 kilo ohm, 10 kilo ohm, each required 1 number. Come to the capacitors. We will perform this experiment for two different capacitive values, 0.1 microfarad and 0.22 microfarad. IC741, 1 number is needed. Oscilloscope, breadboard, each 1 number is needed. Connecting wires and probes as required. In this experiment, the main component is IC741 operational amplifier. IC741 chip looks like this. It has a 8-pin configuration. Okay, we can identify the 8 pins as follows. If you observe here, you will have a parabolic cut like this. Right hand side of that parabolic cut, the pin number 1 starts. The pin number 1 is offset null. The pin number 2 and 3 are inverting input pin. 3 is non-inverting input pin. Pin number 4 is negative power supply, that is minus VCC. Then you need to turn like U-turn. Pin number 5 is again offset null. Pin number 6 is will take the output from that pin. Pin number 7 is positive power supply plus VCC, and pin number 8 is NC, not connected, that is dummy pin. In these 8 pins, we'll mainly use the 2 input pins, 2 and 3, inverting input and non-inverting input, and 2 powers, that is positive power supply and negative power supply, 7 and 4. We'll take output from the 6th pin. This is the circuit diagram. We can observe in this circuit diagram, we will have a operational amplifier IC741, which will work as a inverting amplifier. And the output of this inverting amplifier is fed back to the input via this RC ladder network. This feedback network contains 3 identical RC networks, which will work as a feedback network. Okay, we know feedback oscillators contains amplifier and a feedback network. We'll see the theoretical concept and principle related to this experiment. First of all, what is an oscillator? Oscillator is an electronic circuit that generates a periodic waveform without giving any input. The oscillator can generate a waveform like sine wave or square wave or triangular or sawtooth wave. You can observe the simple block diagram of oscillator here. There is no AC input here. We'll simply switch on the power supply. Then oscillator starts oscillating and it will produce different kinds of waveforms. If the oscillator produces sinusoidal oscillations, those oscillators we will call it as feedback oscillators. The oscillators will generate square wave, triangular or sawtooth waveforms. Those kind of oscillators we will call it as relaxation oscillators. In this experiment, that is RC phase shift oscillator, it is belongs to feedback oscillators. Oscillator is nothing but, especially feedback oscillator, an amplifier with positive feedback will work as a oscillator. To get the sustained oscillations or sinusoidal oscillations, the feedback oscillators must satisfy these two conditions. These are called Bark-Husson's criterion. The first condition is the magnitude of the loop gain, that is mod A beta, must be equal to 1 or slightly larger than 1. In practical, it should be slightly larger than 1. The second condition is the phase shift of the loop gain must be either 0 degrees or 360 degrees. These two conditions must be satisfied. Then only a feedback oscillator can generate sustained oscillations at the output, sustained sinusoidal oscillations at the output. Come to the RC phase shift oscillator. We have already seen the circuit diagram. The RC phase shift oscillator uses op-amp, which works as a inverting amplifier. That means if you give the input to the inverting pin, at the output side, the signal will get 180-degree phase shifted version. And it also contains feedback network. In the feedback network, we will have 3 RC networks are there. Each RC network will provide 60-degree phase shift. Then on a total, 3 RC cascaded network will provide 180-degree phase shift. And operational amplifier, it works as an inverting amplifier mode. That means it is also providing 180-degree phase shift. Then on a total, the whole loop will have a total phase shift of 360 degrees, so that it satisfies the one of the condition of design criteria. And also another thing it needs to satisfy is the loop gain must be equal to 1. If you see, the feedback factor for the feedback network is 1/29 for this RC network. To get a loop gain of 1, the gain of the amplifier must be 29. Then only it will produce sustained sinusoidal oscillations. The circuit will oscillate at this specific frequency. That means the frequency of oscillations for the RC phase shift oscillator we can get from this formula. Frequency of oscillations is equal to 1/2 pi root 6 RC. Okay, that means the frequency of oscillations is mainly depends upon these R and C values, which is from the feedback network. We'll do the theoretical calculations for the frequency of oscillation. Frequency of oscillation is equal to 1/2 pi root 6 RC. In the feedback network, we used R value as 3.3 kilo ohm. Capacitive value, one case we will use 0.1 microfarad. Then if you calculate in the first case, the frequency of oscillations comes out to be 196.96 Hz. In the second case, I'm using the same resistive value, that is 3.3 kilo ohm. Capacitive value I'm changing to 0.22 microfarad. Then in this case, the frequency of oscillations comes out to be 89.53. Hz. These are theoretical values. This is the expected output waveform. We can observe it in the CRO, that is sinusoidal oscillations we can observe in the CRO if you do the experiment in the lab. From this waveform, we need to calculate the peak to peak voltage and also the time period. If you know the time period, we can easily find out the frequency. Frequency is equal to reciprocal of the time period. Then we need to finally we need to fill the this table for two different capacitive values. What is the theoretical frequency? What is the practical frequency we observe in the lab in the oscilloscope? Now we'll move to lab and we will do the experiment and see what is the practical frequency comes out to be for the two different capacitive values. Students, now we are going to do the experiment RC phase shift oscillator using IC741 operational amplifier. I already explained the concepts and principles related to this experiment through PPT presentation. In that presentation, I already shown you the circuit diagram. This is the circuit diagram to perform the experiment. First, connect the components as shown in the circuit diagram. Here in the breadboard, if you observe, you will have capacitors, resistors, IC741 op amp. And also we will have equipment, dual mode power supply and oscilloscope. In dual mode power supply, I set 15 volt DC power supply. I am using both the channels. From channel 1, I am taking the positive supply voltage and giving it to the pin number 7. And ground is connected to the ground. And from channel 2, I am taking the negative terminal and I am giving it to the pin number 4. That means I am applying positive voltage plus VCC and I am applying negative voltage minus VCC. Then I am taking another wire from pin number 6. Pin number 6 we will take the output that is connected to the oscilloscope channel X. Then we will get the output waveform like this. That means this oscillator is producing sinusoidal output waveform. If you observe the frequency here, it is 86.58 Hz. From this waveform, we will observe the peak to peak voltage and as well as the note down the practical frequency. In this circuit diagram, I have used capacitive value as 0.22 microfarad. Now I am changing the capacitive value to another capacitive value, that is 0.1 microfarad. Then if you observe in the oscilloscope, you are again getting sinusoidal wave. For this sinusoidal wave also, please note down the peak to peak voltage and as well as the time period. From the time period we can calculate the frequency. Okay. We have observed output waveform as well as the practical frequency for this RC phase shift oscillator for two different capacitive values, that is 0.1 microfarad and 0.22 microfarad. I already explained you to calculate theoretical values for these two capacitive values.